Okay. So, okay. Hi friends. My name is Souvik Saha. I work as a front-end engineer in the Outlook team for mobile web at Microsoft. In coming 30 minutes, we'll be diving deep in JS modules for the first 25 minutes, and then we'll love to take questions in the last 5 minutes. So please note down any question that you'll have during the presentation, and also do note that this is my first time talk, so I'm a bit nervous. So please excuse me if I go wrong somewhere. So let's start. So today's agenda is we'll talk about basic requirements for a maintainable code base. Then why don't we use just files? Why do we need modules? And what is a module? Then we'll go to explain the evolution of JS module system over time. So what are the basic requirements for a maintainable code base, right? So a code base should be easy to read, easy to understand and maintain, and should be less coupled, right? So thinking about this, the brute force approach would be to distribute the code base in multiple files, right? But just distributing it in files won't work, because we have few caveats in files. So what are those? The first thing is files share same global namespace. Second is they interfere with each other's bindings. And the third is uh, our dependencies are unclear when we use files. So what does modules provide us with? So it makes code base easy to read, easy to understand, maintain. It provides abstraction. It provides isolation as well. So no interference with each other's bindings, and also so no effective sharing of global namespace as well. So and modules also provide reusability. Now, what is a module, right? So I'd like to take an example, like not example, it's an analogy. So modules are like car wheels. Like just like cars depend on its wheels for its movement, a program depends on modules for its functionality. Also, wheels of a car are designed in a plug and play kind of reusable approach, right? So modules are also designed to act in program in that. So knowing what is modules, now let us uh, quickly go through the four basic primitive module systems that have evolved over time. So these are the four. The first one is revealing module pattern. Then came the CommonJS. After that, AMD, followed by S6. Now let's start with the first module system. So this is called revealing module pattern. So in this module system, we try to implement the module system with immediately invoke function. So you can see the highlighted part in the code. So we have a function which is getting immediately called after its definition. So this is called immediately invoke function. Why are we using that? So because of this, we are creating local scope, and this helps in preventing the second disadvantage of file system, which is interfering with each other's bindings, right? So and also in this module system, we have this module interface, which is just returning a object as a module interface. So let's examine this example. So I've taken a simple code to explain RMP. In line number 2, we have a variable named cat, so which is assigned to a string Tom, and we are just returning a module interface, which is nothing but an object having a property called getCatName, which is a function returning the cat name. Now, since it is immediately invoke function, this module interface will get assigned to the Tom and Jerry variable that we have in line number 1. And after that, we can just go in line number 10 and log the cat name in console. This is simple module pattern code, right? So now I want to use this Tom and Jerry object in a separate module. So this way we can do this. So I have two files here, tomandjerry.js, and the second one as cartoonnetwork.js. So, and the whole setup to work, you need one HTML file which will uh, require, which will basically use these two scripts in its script tag, and that will make the entire thing work. Now, so the main thing to note here is, if in cartoon network.js file we have that Tom and Jerry object, right? In line number 3, we're using Tom and Jerry dot get catname. So one thing to note here is, so we have not defined a Tom and Jerry object anywhere in cartoon network.js, right? But how are we getting this Tom and Jerry object? How does the JS runtime know from where are we getting this Tom and Jerry object, right? So it's the answer is because of the first problem of file system, which is they're sharing same global namespace, and because of which the JS runtime gets the Tom and Jerry object from Tom and Jerry.js file. So this was the problem in file systems also, right? So what are we solving here then? So this is what we have solved. So we have only solved one part of the one of the three disadvantages of files, which is the second one, interference with each other's bindings. And this is solved because of the local scope that we created with the immediately invoked function. Now we still have two unsolved problems here. First is file share, these two modules also share same global namespace, and the third one is the dependency unclear problem, right? So if I explain this problem in line in file cartoon network.js, you'll see I'm using Tom and Jerry object, but I'm not explicitly specifying from where I'm getting this Tom and Jerry object, right? So let's try to improve this a bit. So targeting the first problem, which is file share same global namespace. So this is simple to solve. We just need to run each module in its own scope, and we'll get done with it. Now the main thing to solve here is the second one, the second unsolved problem, which is dependencies unclear. Let's see how we can solve this. So to solve this, we need to explicitly declare a dependency like this one, the highlighted portion, line number 3. So we'll just say include this Tom and Jerry object from Tom and Jerry .js, and we should be able to do this. But the thing here is, since we are running each module in its own scope, so just writing that one line of including won't work. So what we need to do is, we need to be able to load the file CommonJS and run it so as to make the Tom and Jerry object ready for consumption, and then in cartoon network.js we can consume that Tom and Jerry object, right? So the problem now boils down to two stages in pipeline. First is load file and then run it. Now load file, if you go deeper, so it is just fetch that file and read it. And both these problems are solved by typical JS APIs, and we get the result as file contents in raw string form, right? Now first part of the pipeline can be easily solved. The second stage is we need to run the JS contents, JS file contents, which is in raw string form, and we just need to run that part. So our input is string, but we need to run it as JavaScript. So to solve this problem, JavaScript provides two tools, and these are eval function and function constructor. So eval function, those who don't know eval function and how function constructor works, I'll explain function constructor in a bit late in this slide, in upcoming slides. Let's talk about eval function. Eval function is a function which takes a JS expression in string format and just runs it. Whereas the function constructor also does the same. It takes input JS expression in string format, but it creates a function out of it, which we later need to run. Now, the difference between these two are stated in the slide, which is eval is a slow function, whereas function constructors are fast, and eval runs in the parent scope, and whereas function constructor runs in its own scope. So it is a clear choice that we'll be using function constructor, right? So using function constructor, we can solve the second stage of the pipeline, which is running a string JS code, which is in string format. Now, with all these observations, we are now ready for the improvement of revealing module pattern. And all these logics went into the psychology of making CommonJS module. So let's just see how CommonJS tackles all these problems. So I'll go to CommonJS. Yes. So in CommonJS system also, I've used the same Tom and Jerry theme of printing the cat name using the two files tomandjerry.js and cartoonnetwork.js. So we all must be familiar with this syntax of require and exports and all. But the key thing to note here is this require. So how does this require function works, right? So I'll be revealing that in this slide. So there are a bunch of works which you do here. Let's just put the cache part aside and just focus on the basics. So let's start with line number 5. So let code equals to read file name. So if you remember the improvement logic that we all discussed, right? So we have two stages in pipeline. First is load file and then run it. So this particular line of code, which is line number 5, right, in required.js. So this deals with the first part of the first stage of the pipeline, which is load file. So if you are confused about what exactly is this read file doing, it's consider it as abstraction. So suppose we require commonjerry.js, right? So read file will fetch that file and will read it in raw string format. So I have this Tom and Jerry file that you see in the upper screenshot, which is getting converted into raw string form, and at the end of it, it will get assigned to the variable code in line number 5. After that, we go to line number 6 and do some bunch of initializations, some metadata for module. In line number 7, we initialize an exports object. Here we'll put the module interface of like for tomandjerry.js, whatever exports we'll be doing, we'll be putting all those exports in this particular exports variable, and then we'll put it in cache, and after that we'll prepare for the second stage of the pipeline that we discussed, which is run it part. So we talked about this function constructor, right? So let's see how we use this and what it does. So again, taking the same example of required tomandjerry.js. So what does function constructor do? So if you observe the code closely, so the second parameter of function constructor, which is code, we have the raw string form of tomandjerry.js file stored in code, variable code, right? So what function constructor does is it creates a function, as you see in the lower screenshot, function fn. It takes and the parameters as written in function first argument, and then makes the code part of the function constructor as the function definition. So that's how function constructor works. So now after creating this function, what we do is we assign this function to wrapper, and in line number 10 we'll call this wrapper function, which is the is equivalent to performing the run stage of the pipeline that we discussed in the improvement, right? So now what exactly are we doing in wrapper? We're just running this particular function, which in turn will run this code written in the function definition, which is nothing but the tomandjerry.js file code, right? So the key thing to note here is, since we are running this tomandjerry.js file, JS module in a wrapper function, right? We are getting local scope out of the box. So because of this local scope, so we solve the second problem of file system, which is interfering of one module with another. So we solve that because of this local scope, and also since the entire part of the module gets wrapped in the wrapper function, so we effectively we are not sharing the same global namespace. So then uh, so the two disadvantages are solved here, and also the third one, which is dependency unclear part, is also solved because we are explicitly saying that I want to require Tom and Jerry Rogers. So that's how from require function we are solving these three disadvantages. Now let's go and complete this require function. So yeah, so in the last line we'll just return the module interface, which is nothing but that object where whose property is get cat name, and that's it. That's how require works. So now that's pretty interesting that require works this way, but there are a few caveats in require function as well. So the first one being, require function is blocking. So by blocking, it means whenever I am having two requires, right? So the second one won't start after, before the first require ends. So till that time the code will be blocked, right? So this is because CommonJS was built with server-side development in mind. So due to this, it is not suitable to be used in client side, because as you know, require consists of two stages, right? Load and run. So run part is not a problem for client side, but load part becomes a problem if if that particular file is not present in client side, because then we need to go to server and fetch it from server, then read it and then run it. And till all that time, our UI will be frozen. So it's so that's why CommonJS is not that suitable choice for client side development. So that is one of the disadvantages of it. And the second disadvantage is, although we have explicitly declared the dependencies like require Tom and Jerry.js and require Augie and cockroaches. So but to get the entire dependency graph of an application, we need to run all the modules in the dependency graph. So and that so we can't use static analyzer tools, some sort of that. So that is another disadvantage. Now knowing all these disadvantages, let's see who all uses CommonJS. So we have this Node, Browserify, Webpack, all these use CommonJS. Now let's move on to the next third module system, which is AMD. So AMD stands for Asynchronous Module Definition. So from the name, you can quickly infer that this is a module which supports asynchronous loading of modules, and so it will be greatly useful for client side, right? So yes, that's right. So I'll again take the same theme of Tom and Jerry and print the cat name. So in this model, AMD model system, right, we have a special function called define that you can see in both the modules that I've written. So define define takes two parameters. The first one being the dependency array, where we define the array of modules that is required for this particular module to run. And the second part goes as the code of this particular module, right? So I will not delve too much deeper in AMD, but that's the point that we use this AMD more in client side kind of thing because of its asynchronous nature, and it's most suitable in client side. And also because of the dependency array, we can build the entire dependency graph without running the modules in the dependency graph. So but the disadvantage of AMD is like its signature is a bit complex, and we need for some browsers it is not supported, so we need to polyfill in those browsers. Now let's see who all uses AMD. So there is a library called require.js, and there is a something called dozo. So these all uses AMD. Now let's move on to the last module system of our talk. So that is ES6. So this particular module system is native support from JS, and it is integrated directly into the language. So it also supports asynchronous mode. Again, I'm using the same Tom and Jerry theme of printing the cat name. So then we all have been using this export and import lines, right, for getting our job done. But just as we know how require function works, we would like to know that how this import works, import and export coordinates to get our work done, right? So and how we build the whole dependency graph, how the asynchronous stuff works. So all that we'll answer if we deep dive in ES6, right? So let's deep dive and find the answers there. So ES6 has 3 steps in pipeline. So the first being the construction, the second one is instantiation, the third is evaluation. To get the sense of what each of these are doing, let's first make sense of these 3 stages with the CommonJS counterpart code that we saw, right? So let's see the CommonJS code. So this is the code that we saw just now. So now let's let's segregate its logic into these 3 stages. So that's what it is. The construction corresponds to the load stage that we talked about in require function, right? And evaluation corresponds to the run phase of the pipeline. And we have something called instantiation, which goes in between. It's just wiring up of memory, wiring up of variables to memory. So that's how we link it to CommonJS. But now there comes a question that since these 3 pipelines are there in CommonJS as well and also in ES6, how is ES6 managing asynchrony, whereas CommonJS is not able to do? It does in it does in synchronous way, right? So the answer here is CommonJS applies these 3 stages of pipeline for every module it runs, whereas the ES6 runs these 3 stages for the entire module dependency graph. So, and that's where the difference lies. Let's see how it does. So let's take an example, some different example this time, because we all might have got bored with the Tom and Jerry kind of stuff. So let's take a simple example. So the first, we have a main.js file which imports count variable from counter.js file or module, and we'll import render function from display.js file. Okay, so then we have in line number 5 render count. So render is a console log and count is 5. So at runtime we should be able to see 5 logged in console. So that's the simple code. So now let's try to understand the 3 phases of the pipeline in context to this particular example, right? So let's start with the construction phase. So construction phase is nothing but it takes an entry point JS module, and it goes and creates module records, a set of module records, each for each module in the dependency graph. So what are module records? Module records are nothing but it contains it is a data structure which contains data about a particular module, like what all import variables is it using, or what all files it is dependent on, and more such kind of stuff. Now having this module having known this module record, let's go to the objective of this construction phase, right? So we have a entry point JS file and we need to create a bunch of module records. Now for those who know Webpack also does this as one of its tasks, but we will not talk about what Webpack does, because we'll imagine some time where Webpack was not there and it's just pure JS. How should we achieve it, right? So then this is how we do it. So we just put the entry point main.js file as source in script tag, and put the type as module, and the JS runtime will then go and fetch this particular main.js file. It will pass it into module records. There it will know that it needs counter.js and display.js files. So it will go and parallelly fetch these two files, and then will pass it accordingly to their module records. So this way you can go recursively build the set of module records required for our construction. So till now all's good, but there is a slight thing to consider here. So the thing is, what uh, what happens if we need some lazy loaded code, right? So I want some part of code which is to be loaded when I do some button click or any such kind of thing. I need some dynamic import kind of thing. Not at the first load I want all the modules kind of thing. So the problem here is, how do we do dynamic imports, right? So the ECMA team gave us a API called import, which solves this problem. So how do we use this? We use this import like this. So import takes a module name, and what it does is it starts a separate dependency graph from that particular entry point, and it loads that code whenever it's needed. So that's how we do dynamic imports. I'll not go deeper into import, but just shown how do we use it. For the interest of time, I'm not going deeper into import. uh, Now, having said that, we have covered the construction phase of our ES6. Now, let's go to our instantiation phase. So, instantiation phase is simple. So, the objective here is we need to wire up the import and export variables of each module to the two particular memory locations. So we have a concept of memory. So we have a concept of module environment record here. So so at the end of construction phase, we have created a bunch of module records, right? One for each module. So now at the end of instantiation phase, we'll be creating module environment records as well. So one for each module. Now, what these module environment records will contain all the import and export variables required for a particular module, and it will also store the particular memory location to which those import export variables are wired to. Now the key thing to solve here is, in what order do we instantiate the import and export variables to the memory, right? So the answer here lies in this particular slide. So this is a simple animation. We do it in depth first traversal strategy. So like as you can see, the exports of node 4 and node 5 will get wired first before import of 2 gets wired. Similarly, export variables of 2 and 3 gets wired first before wiring of imports of 1. And that's how we solve the order uh, of instantiating the import and export variables. So having said that, we have now solved this instantiation part as well. Now let's go to the evaluation phase. The evaluation phase is more simple. The thing is, once we are done with the wiring up of imports and exports, we just now go and just run the code, and that's how we get the 5 value in the memory location of count, and we use it in our main.js file and just do console log on that. So that's how the ES6 3 stages works under the hood, and that's it. So that's all I wanted to share with you. So I think I'm open for questions now.
Yeah, hi.